everyone. My name is Joe Mann. I'm a staff cloud solution architect with the Worldwide Cloud Practice Program here at VMware. In this session, we're going to have a look at modern application platforms within the VCPP program, specifically kind of the state of play today with respect to the container service extension integration with VMware Cloud Director, as well as an overview of the Tanzu Run portfolio and how that's going to fit in to the stack in the future. But first, I just want to talk a little bit about general, practices within the cloud native community. So, since applications have become a core competency for enterprises, application velocity as well as customization have really become critical to driving competitive advantage. So the speed at which lines of businesses can evolve their applications to meet their customers' needs provides, what we feel is a true competitive advantage. So cloud and service providers are really looking to work with the likes of VMware to create infrastructure and platforms and environments that allow for this kind of velocity of application creation. So the technology at the base of this movement is containers and containerized workloads. So containers have three crucial capabilities that give them kind of the best positioning to enable this velocity of application development. One of them is speed. So they're very fast, which enables developers to kind of implement and test rapid changes at a rapid rate. Second and third, they're lightweight and portable. So you can develop an application on your own workstation within a container, and then move that application to all the way up to your prod environment running on-prem or off-prem, and you have a high degree of certainty that application is going to run and be as performant as it was on your laptop. So when that app lands in new environments, there's a very high degree of certainty that it will run. But if we're talking about application modernization, we can't just drop an existing, what we call monolithic application into a container and call it a day. It's more about a shift in application design away from a single large code base running in a virtual machine or maybe even running in a container towards more of a microservices type deployment. So the microservices architecture allows for that rapid evolution, scalability, availability of applications. Modern applications are normally based on distributed microservices. So what is a microservice? A microservice is just a modular piece of a larger application. So for example, a payment function of an application could be considered a microservice. And so these microservices are small pieces of code or application components that normally have well-defined interfaces, generally APIs. So what are the actual benefits of designing applications with kind of a microservice methodology? So if you're counting on your application as a primary driver of revenue, it's important to have that app available 24/7. And developing an application with the microservice methodology is a great way of ensuring that. So microservices ensure modularity, scalability, speed, and high availability. So they since the code is broken down into small chunks that have well-defined interface, very modular, we can develop these components of the application in parallel. And so this allows for speed because we can enable and develop modules in parallel one at a time instead of having to develop these things in series using more of a waterfall methodology. Scalability is important. We can scale independent components of the application as needed. And then finally, availability. So if these components of our application are distributed across multiple nodes or sets of infrastructure, we have a high degree of certainty that our app will have a high degree of availability. But as you can see from this kind of simple example of the diagram, there's a lot of pieces to the puzzle. And how do we ensure that all of these microservices can communicate with each other? How do we ensure that they're monitored and their health is monitored? And that's where a container platform comes into play. So modern application architectures require a container platform. So there are a lot of container orchestrator systems out there, but as you can see from this Cloud Native Compute Foundation study back in 2018, 80+% of organizations are utilizing Kubernetes to provide container orchestration systems. So we believe, kind of like the rest of the industry, that this decision has already been made in the field and that we're well positioned to help our partners invest in Kubernetes knowledge and infrastructure to support Kubernetes clusters and workloads. So now, how are we bringing that into the VMware Cloud Provider Program, and specifically, how are we tying it in with VMware Cloud Director? And that's where the Container Service extension comes in. So the Container Service extension brings Kubernetes as a service to VMware Cloud Director environments by automating the creation of Kubernetes clusters. Obviously, we utilize existing tenancy within VMware Cloud Director, so providers can onboard this service to existing tenants. CSE handles day 1 and day 2 operations for the cluster, so creating, scaling and resizing, updating and patching the cluster. We offer two main flavors, if you will, of CSE: CSE Standard and CSE Enterprise, and we'll go into the differences in the next couple of slides. Very lightweight server as far as the server component of the solution, and can easily be dropped into existing VMware Cloud Director deployment. So we'll have a look at the architecture. We also are going to post an accompanying video and demo for the solution as well, to maybe provide an additional context. The Container Service extension essentially allows providers to offer Kubernetes as a service to their tenants, and utilizing the VMware Cloud Director tenant portal to provision and manage these clusters as they would with their other vApps or virtual machines in VMware Cloud Director environments. So first we'll talk about CSE Standard, and this is really the basis or the foundation of any CSE deployment. So this CSE Standard basically utilizes some customization scripts on the CSE server and vApp templates provided by VMware to create and instantiate Kubernetes clusters. So these are Kubernetes clusters as vApps in VMware Cloud Director. So very similar to traditional vApps as they exist today. VMware just provides vApp templates that have a defined operating system, Kubernetes version, container network interface version. We use Weave as the container network interface in CSE Standard clusters, as well as Docker version. So we have right now 4 different templates with various versions of Kubernetes, a set of templates with an Ubuntu OS, and then a template with a Photon OS as well. So this is available to providers at no additional cost. The provider is obviously responsible for reporting usage of the virtual machines that underpin the Kubernetes environment, but there is actually no additional charge for the CSE component. This can utilize NSXV or NSXT-backed provider virtual data centers, but there are certainly some considerations, and we'll call them kind of gaps today with CSE Standard, in that there is no container network integration with NSXT, utilizing the NSX container plugin, and HA master or high availability control plane deployments are not supported. So in order to get those features and functionality, CSE Enterprise is available. So now CSE Enterprise is essentially an adapter that allows providers to bring Tanzu Kubernetes Grid Integrated, formerly known as VMware PKS, into the VMware Cloud Director environments, and allow users to utilize the same tenancy structure and UI plugin to provision PKS clusters via VMware Cloud Director. So this solution, CSE Enterprise, is really entirely dependent on TKGI or PKS. As such, it requires NSXT-backed provider virtual data center, but because of that, it is able to use the container network automation, interface automation provided by the NSX container plugin to provide all sorts of network integrations with the Kubernetes clusters. As I mentioned earlier, high availability control plane deployments are supported with PKS. Dynamic storage provisioning is provided by the vSphere container storage interface. Harbor container registry support is also provided as part of the PKS consumption. And essentially the takeaway here, and we'll talk about this a little bit in the architecture overview, is that the heavy lifting is done by the PKS control plane. So CSE just essentially acts as a shim or a go-between between the VMware Cloud Director tenant portal and the PKS environment to pass commands and information between the two. So if we have a look at the component walkthrough and kind of who's responsible for which layer of the solution. So the cloud or the system admin is responsible for deploying VMware Cloud Director cells RabbitMQ or AMQP server is used for extensibility and a message bus between the CSE server and the VMware Cloud Director cells. So the CSE server is just a Linux installation. We utilize Python version 3.7.3 or later to automate the creation of these clusters. So you can utilize any Linux server that will support Python 3.7.3 or later, and then use pip to install the container service extension server components. And then when performing the install, essentially the CSE server connects to the AMQP service, creates a new exchange, and registers that with the VMware Cloud Director environment, and then pulls the VApp from the public VMware repo and creates a VApp template that will be used when Kubernetes clusters are created by tenants. So that's basically a high-level overview of the installation process. Then the system admin enables specific orgs or groups of orgs to support CSE cluster creation. As part of the CSE server installation, there's a custom rights bundle that's installed and is given to the system admin user automatically, and then they can grant that to use that to enable orgs and grant org admins the ability to provision CSE clusters, and then the org admins can pass that right along and assign it to users within their environment. So they would assign this custom rights bundle to the tenant developers, and then the tenant developers would log in to the tenant VCD tenant portal and utilize this new CSE UI plugin to create their cluster. And so once that process happens, this triggers the CSE server to automate the creation of the Kubernetes nodes, the VMs that support those nodes, instantiate them as a Kubernetes cluster, and then allow the tenant developers to interact with those clusters as they would any other Kubernetes cluster. So that's the process for CSE standard or native Kubernetes cluster creation. If we have enterprise PKS in the picture and we're doing CSE enterprise, that same user would go through the same dialog in the tenant portal to create their cluster, except they would choose the organization virtual data center that's enabled to support enterprise PKS, as we see highlighted under the Kubernetes provider menu or title in the screenshot. So once that process happens and the cluster creation is initiated, the CSE server reaches directly to the PKS API and the NSXT APIs to create the PKS resources. So we don't actually see the creation of a typical VApp. CSE just acts as a go-between to create the cluster and via the PKS API. The tenant developer still uses the same menus in the VCD tenant portal to interact and create and view the clusters. It's just depending on what service they're enabled to use with their rights bundle and what org VDC they choose to deploy their cluster in. So this is a high-level diagram that's just kind of meant to reinforce kind of the roles and responsibilities of the stack of the solution, where the system admin owns the SDDC stack and the CSE server installation. The org admin owns the org VDC level, being able to define which org VDCs are enabled with which Kubernetes provider, and then assigning tenant developers certain rights to provision or view clusters in certain org VDCs. So you as a tenant or org admin or an organization could have multiple org VDCs enabled for different types of providers. So essentially CSE at the end of the day is the kind of the go-between from VMware and then additional, today CSE standard and enterprise with PKS Kubernetes solutions, but the vision is that CSE will continue to allow onboarding of additional Kubernetes solutions like the Tanzu portfolio, which we'll take a look at in part 2 of the series.